Stars are born. In the vast cold expanse of space, clouds of gas and dust come together, pulled by the force of gravity. These clouds, known as nebulae, are the stellar nurseries where stars are born. Over millions of years the gas and dust coalesce, heating up and igniting nuclear fusion in the core, giving birth to a new star. Stars live. They shine brightly, illuminating the cosmos and providing warmth and light to any planets that may orbit them. And stars die. Their lifespans can range from a few million to several billion years, depending on their size and mass. But some stars don't fade away quietly. They go out with a bang, a supernova. This cataclysmic event is one of the most powerful explosions in the universe, releasing more energy in a few seconds than our sun will emit in its entire lifetime. Imagine a star, much bigger than our sun, nearing its end. These massive stars, often more than 8 times the mass of our sun, have spent their lives fusing hydrogen into helium in their cores. It has burned its fuel for millions or even billions of years. As it ages, it begins to fuse heavier elements, creating layers like an onion inside the star. Now it's running out of hydrogen, the fuel that keeps it shining. The core contracts and heats up, trying to find new sources of fuel, but eventually it can no longer sustain nuclear fusion. Without fuel, the star's core starts to collapse under its own gravity. This collapse is a dramatic and violent process, causing the outer layers of the star to fall inward. This collapse happens incredibly fast. In just a matter of seconds, the core shrinks to a fraction of its original size. Temperatures and pressures in the core skyrocket. The core becomes so hot and dense that it triggers a runaway fusion reaction. Then, boom! The star explodes with the power of a billion suns. This explosion, known as a supernova, sends shockwaves through space, creating new elements and scattering them across the universe. The explosion is so bright it can outshine an entire galaxy for weeks or even months. The light from a supernova can be seen across vast distances, sometimes even from other galaxies. This, my friends, is a supernova, the spectacular death throes of a star. It's a reminder of the incredible forces at work in the universe, and the cycle of birth, life, and death that governs all stars. What makes a star go supernova? It all comes down to what's happening deep inside the star's core. There are 2 main ways a supernova can happen. Let's call them Type 1 and Type 2. Type 1 supernovae involve 2 stars locked in a deadly dance. One star is a white dwarf, the dense leftover core of a star like our sun. The other star is often a red giant, a star nearing the end of its life. The white dwarf, with its strong gravity, acts like a cosmic vampire, sucking material from its companion star. This stolen material builds up on the white dwarf's surface. Eventually, the pressure becomes too much. The white dwarf can no longer support its own weight. It collapses and explodes in a blinding flash of light. Type 2 supernovae are more straightforward. These cosmic events are among the most powerful and dramatic phenomena in the universe. These explosions involve massive stars, at least 8 times the mass of our sun. Such stars live fast and die young, burning through their nuclear fuel at a rapid pace. These stars are like cosmic pressure cookers. Inside their cores, nuclear fusion reactions generate immense amounts of energy, creating a delicate balance between gravity pulling inward and pressure pushing outward. They fuse hydrogen into helium in their cores, releasing enormous amounts of energy. This process, known as stellar nucleosynthesis, is what makes stars shine so brightly in the night sky. As the star ages, it starts to run out of hydrogen. The core contracts and heats up, causing the outer layers to expand and cool, transforming the star into a red giant. It begins to fuse heavier elements like helium into carbon, carbon into oxygen, and so on. Each stage of fusion releases energy, but not as much as the previous stage. This process continues until the star's core is made mostly of iron. Iron is unique because it doesn't release energy when it fuses. Instead, it absorbs energy. Iron is the end of the line for stellar fusion. The core becomes inert, unable to produce the energy needed to counteract the force of gravity. When the core can no longer support itself, it collapses. This collapse happens in a fraction of a second, causing temperatures and pressures to skyrocket. The collapse triggers a shock wave that rips through the star, blasting it apart in a supernova explosion. This cataclysmic event scatters the elements forged in the star's life into space, seeding the cosmos with the building blocks of new stars, planets, and even life itself. Section 3, Cosmic Alchemy Forging the Elements. Supernovae are nature's grand alchemy labs. They are responsible for creating many of the elements that make up our universe, including the elements that make up you and me. Remember how massive stars fuse lighter elements into heavier ones? Well, the intense heat and pressure of a supernova explosion allow for the creation of elements even heavier than iron, like gold, silver, and uranium. These elements are scattered into space by the force of the explosion. Over time, they become part of gas clouds called nebulae. These nebulae are the birthplaces of new stars and planets. Section 4, Scattering the Seeds of Life. Supernovae don't just create elements, they are the universe's grand alchemists, forging elements in their fiery cores. When these massive stars reach the end of their life cycles, they explode in a spectacular supernova, releasing an immense amount of energy and newly formed elements into space. They also scatter them across vast distances, seeding the universe with the building blocks of planets and life. These elements, such as carbon, oxygen, and iron, are essential for the formation of planets, moons, and even the very life forms that inhabit them. Imagine the shockwave from a supernova explosion as a cosmic broom, sweeping up the surrounding interstellar medium and pushing it outward. This shockwave travels at incredible speeds, sometimes reaching thousands of kilometers per second, and it carries with it the raw materials needed to create new celestial bodies. This interstellar medium is a mixture of gas and dust, including the newly forged elements from the supernova. As the shockwave moves through space, it compresses these materials, creating dense regions where gravity can take hold and begin the process of star formation. The shockwave compresses this material, triggering the formation of new stars and planetary systems. Over millions of years, these regions can collapse under their own gravity, forming new stars and the planets that orbit them. This cycle of death and rebirth is what drives the evolution of galaxies and the diversity of the universe. Without supernovae, the universe would be a much less interesting place. These cosmic events are responsible for the rich tapestry of elements that make up everything we see around us. They are the reason we have the diversity of planets, stars, and even life itself. It would be mostly hydrogen and helium, with few of the heavier elements needed for planets and life as we know it. The universe in its infancy was a simple place, but thanks to the powerful explosions of supernovae, it has evolved into a complex and vibrant cosmos, teeming with the potential for life. Section 5, Stellar Nurseries, from Supernovae to Starbirth. Supernovae play a crucial role in the cycle of stellar birth and death. Remember those nebulae we talked about? They are stellar nurseries, where new stars are born from the ashes of old ones. The shock waves from supernova explosions can compress the gas and dust in these nebulae, causing them to collapse and ignite new stars. In a sense, supernovae are like cosmic gardeners, tilling the soil of interstellar space and planting the seeds for future generations of stars. Our own solar system may owe its existence to a supernova. Scientists believe that a nearby supernova explosion about 4.6 billion years ago may have triggered the collapse of a giant molecular cloud, giving birth to our Sun and the planets that orbit it. Evidence for this supernova comes from the presence of certain radioactive isotopes in meteorites, which are remnants from the early solar system. These isotopes are thought to have been injected into the solar nebula by a nearby supernova explosion. Supernovae leave behind more than just scattered elements. They also create some of the most extreme objects in the universe. One possibility is a neutron star, an incredibly dense ball of neutrons left behind when a massive star's core collapses. Neutron stars are so dense that a teaspoonful of their material would weigh billions of tons on Earth. Another possibility is a black hole, an object so massive and dense that nothing, not even light, can escape its gravitational pull. Black holes are regions of space-time where gravity is so strong that it warps the fabric of the universe. Supernovae may seem like distant events, but they have a profound connection to our own existence. The iron in our blood, the calcium in our bones, the oxygen we breathe, all these elements were forged in the fiery hearts of stars and scattered into the cosmos by supernova explosions. We are literally made of star stuff. Every atom in our bodies has a cosmic history, tracing its origins back to these cataclysmic events. Supernovae are more than just spectacular fireworks displays, they are fundamental forces in the evolution of the universe. They create the elements that make up planets and life, scatter these elements across vast distances, and trigger the birth of new stars. In a very real sense, we owe our existence to these cosmic explosions. The next time you gaze up at the night sky, remember the supernovae, the celestial engines that have shaped our universe and made life itself possible.